Hey guys, Christian here, and today we're taking a look at automating my new self-hosted GitLab platform. As you might know from watching my other videos, I'm using this platform now to store all the deployment files and configs for my HomeLab projects. As you can see, I've got many things deployed here and there, and if you know me guys, you know I'm a lazy dude. Yeah, I hate to create and manage stuff in the web UI. That's why I have automated my entire HomeLab project management in GitLab using Terraform. And Terraform integrates into GitLab in two different ways. First, you can use the Terraform Provider to manage and configure GitLab resources, which is really an amazing way to automatically configure anything in GitLab like repositories, memberships, labels, and so many more things. But there's also another very exciting feature in GitLab existing for Terraform, and that is to use it as a backend for Terraform state files, which is basically a replacement for Terraform Cloud. And that is really great to have a private and self-hosted storage for all your Terraform projects. Let me show you in this video how that all works. Now, before we start with that, I also want to talk about another very important thing in IT, just like automation, and that is cybersecurity. Because the best way to make sure that all your clients, servers, and infrastructure are secured against attackers and malware is to use Wazza, the sponsor of today's video. Wazza is an open source security platform that unifies extended detection and response with a security information and event management system to protect your endpoints and cloud workloads. If you have watched my latest video about Wazza, you know I'm using this on all of my Linux servers and Macs to provide an in-depth analysis of any security events. For example, when somebody tries to log in via SSH and many more things. It has a huge set of pre-configured rules and checks that constantly collect any of those events, and in the central dashboard of Wazza, you can really drill into all of the details, set up alerts, get notified when something bad happens, and this is really amazing. It also has many other cool features like a security configuration assessment that checks your device's config against CIS benchmark lists, and it can even integrate into security tools like ClamAV or VirusTotal. If you'd like to learn more about Wazza and how to use it within your infrastructure, then check out my video tutorial about it, because this is free and open source, it doesn't cost you anything, so there is no excuse for you to not trying out Wazza. Of course, I will leave a link to you in the description box down below. Alright guys, so let's get started with the Terraform Provider for GitLab. By the way, if you're entirely new to this and you don't know Terraform, this is an open source automation tool developed by HashiCorp, which allows you to define and provision your infrastructure as code. Which is basically just a complicated way of saying you define everything in simple YAML files, what your infrastructure should gonna look like, and then let the program create and configure all the resources for you. As you can imagine, this saves you a lot of time, but it also provides you a great source of truth for your environment. So instead of having to go into web UIs and trying to find out what is deployed on your infrastructure, you can just easily look it up in the code. And the cool thing about Terraform as an infrastructure as code tool is that it integrates into all sorts of applications and technologies that are available in the Terraform registry. By the way, I've done many videos in the past using it to provision virtual machines on Proxmox or any cloud resources. I link you some tutorials about it in the description box down below so you can watch it to get started, as well as my first video about my self-hosted GitLab platform if you haven't watched it before. So then you know how to install the whole thing. Make sure to check this out. Alright, so now let's get on with it. As you can see in the Terraform registry, there is an officially managed GitLab provider that we can use to manage GitLab resources very easily in Terraform. So now, to get started, I will just copy what is located under the Use Provider button. So when you click on here, you can just copy a template. Those are the general settings that you need to configure in Terraform to enable the GitLab provider integration. So let's copy this and let's go into my project directory, because I've already created a new project for this. This is, by the way, also managed in a GitLab repository on my self-hosted platform called GitLab Test 1. So here we can store all the code that we need to integrate the GitLab platform in Terraform. Now let's also open this in VS Code so we can better manage it. And I want to start creating the Terraform files in a separate directory that I'm just going to call Terraform. I think this is a better way to manage it instead of just putting it in the main directory of the repo. And let's start by creating another file that I'm just going to call provider.tf for the Terraform file. And here we just paste what we copied from the GitLab provider on the Terraform registry. Now, if you're watching this video a bit later, it might have a newer version, of course, so you can just also add any version that is newer than the version 17.4.0. And of course, we also have to configure some provider-specific options, so that will tell the GitLab provider how to authenticate to your GitLab platform. So if you're using the cloud service GitLab, you don't need to give it any address, of course, because it knows where to look up the official GitLab platform. But if you're running this in your self-hosted environment, you also need to add one parameter here, and that is the base URL. So this is the target base API endpoint URL. So in my case, I will just copy this, and then I'm just going to replace this name here with the DNS name of my self-hosted GitLab platform. In my case, this is going to be GitLab Production 1 on server production 1 home.creative.de. So that's fine. Of course, we also need to authenticate securely with a token. So here we need to put in your personal access token for your user. By the way, if you don't know how to create this, you simply just click on your user button, click on edit profile, and there you can go to access tokens. Here you can create a new access token for any read and write operations on the repository and anything that you need. And then you can put the token in here. Of course, if you don't want to store sensitive information like this in a file that is uploaded to your Git repository, I think this is not a good practice. So what I'm always doing is I'm creating a new variable that I'm just going to call GitLab token. And here in the token flag, I can just use the variable. Now, to store this sensitive information somewhere on your local machine, you can create a so-called auto.tf var file. I'm always using the name secrets. It's not really important what you put in front of that. It just is important that you end it with auto.tf var, so that it's automatically loaded into any Terraform commands that you execute. And here you can just put the value in here. All right, so now that's what we need. By the way, you can see that this file is green, so it would be pushed to the GitLab platform as well. And if you want to avoid this, you can just create a file that is called .gitignore in the main directory, where you put all the files that you don't want to be pushed to GitLab. I'm always just using a template that excludes the auto.tf var file so that the secrets aren't pushed to the GitLab repository and we don't accidentally expose our secret credentials. So now we have everything that we need. Let me just push this for now to GitLab. If you want to learn how to manage any resource in GitLab using the Terraform provider, you can just look it up in the registry documentation here. So here you can see resources, data sources. Let's start with the resources, because those you can use to create specific things in GitLab. For example, you can use it to create a separate branch in a repository. You can use it to create a group, access tokens. You can use it to create badges, even webhooks, memberships of repositories. There are so many things in here. You can even use it to create pipelines, so CI/CD stuff, and automatically manage this. If you want to create a new repository, for example, you have to use the GitLab project, because that's the terminology on GitLab that is equivalent to a repository. So here in this documentation, you can see some examples and templates on how to use it. So let's go back to the project. I want to store this in another file that I'm just gonna call project.tf and paste it in here. So here, this is an example repository that we can manage. I will just call this example 1. My awesome code base, yeah, it's fine. And the visibility level can be set to the 3 levels in GitLab: private, internal, or public. So I will just set it to private. But you can add also any other settings in here just like you want. So for example, if you want to enable or disable the wiki, you can just use this here, wiki enable true or false. For example, what I usually do on my projects that just need to store specific code files, I'm just usually disabling the packages in the auto DevOps features. I don't need this on my repositories. And of course, you can also change any other thing in here. All right, so now let's push this code change as well. Of course, nothing is happening here if I create this repository code, because there's nothing executed in here. To execute the Terraform command, I have to go into this project directory Terraform. And first of all, we need to initialize the project. So I'm just gonna execute a Terraform init command. So this will now download the GitLab provider in that specific version and create the files. If you go into VS Code, you can see where the provider code is located and so on. The log file and stuff is created now. Let's execute the Terraform plan command so we know what Terraform would actually apply on our infrastructure if we would execute it. And here you can see it will create a new project with all the parameters that we have configured. So if you want to apply this, you just execute Terraform apply. And it's going to provide a check where you need to confirm it, and then it's creating the resource. So as you can see, this runs pretty fast. If we go back to our GitLab platform under my current user, you should see a new repository in here that's called example 1. And yeah, we can now clone this. We can now, work on this repository just like we want. I also want to show you some other cool things that you can do with that. For example, you can move repositories to a specific group, even without having to recreate them. Because as you can see, I'm not managing all the repositories for my project under my current user. I'm managing them in a group. And this provides me a great way of managing issues and attaching group labels to them. So for example, you can see all the stuff that I have to do on my HomeLab. I'm starting to create issues, like if I have a bug somewhere. For example, my Longhorn Helm chart is not detected in Renovate, so I have created an issue in that Longhorn repository in HomeLab. And now when I go back to my group and go to my issue board, you can see I now got a Kanban style board with all of the issues and different labels. And one thing that I'm managing with Terraform in GitLab is not just all the different repositories, I'm also managing other resources like this group. I'm managing the issue labels and so on. One thing that is a bit special if you're trying to manage or refer to resources that are already created on GitLab, because as you can see, I have created this group already and I can't create this in Terraform again. However, you can also import those resources, or what you can also do is use the data source. So then I can refer to this object that is already existing. So let's go in here and let's go to data sources GitLab. So you need to start with data, then you're querying objects that are existing. I'm just going to call this HomeLab. And the group ID, you can use the group ID or the group full path, depending on what you like. If you want to refer to the group ID, you can easily look this up in here. If you select the group and copy the group ID, so then you can easily use this. And then if we have the HomeLab group as a data source in Terraform, we can easily refer to this in our repositories. For example, if we want to change the location, let's go back to the documentation in here and let's go to project. Now, here is a flag that is called namespace ID, and this namespace ID should refer to the user ID or the group ID where this repository should be located in. So if we use this namespace ID, we can just refer to that data object that we have created and use the flag ID. Now, if we go back to the Terraform, let's execute the Terraform apply command. So here you can see that it's recognizing, the repository example-1 is already existing, so I don't have to recreate it, but I need to change one specific flag that we changed in the code, and this is the namespace ID from the ID 1. This is probably my user account. Change it to 43, which is the ID of the HomeLab group. So now if we apply this, you can see that when we go back to the repositories, you can see that the example 1 location changed from my user, Christian Lampard, to HomeLab. So now the repository has become a member of that group. And this is how you can easily change all the things that you want to change. Terraform is intelligent enough to know what resources it has created, what settings those resources have, and if it needs to change anything that you change in the code. This is really nice. And yeah, this is how you can easily manage all your resources in Terraform. This is really cool. By the way, I'm just going to show you my production repository. So here you can see I have created all the different repositories that I'm managing in my HomeLab group. I have also added memberships for the Renovate bot, which is nice because the Renovate bot, I'm covering this in a future video, by the way, which is helping you to upgrade all your version dependencies and so on. This needs to be a member of each and every repository. And just imagine I would have to go into all the 30 different repositories that I have, go into the web UI, go into the settings, go into the members section, and then invite the member. Instead, I can just copy this and paste it for all the 30 repos in the code, and I'm done with it. So this is really easy to manage all the different settings. Or, by the way, for creating webhooks, because Renovate also needs a separate webhook where it triggers specific actions happening on the repository, and you have to create this webhook for each and every repository, which can be really annoying. Again, I'm using Terraform to automatically manage and create all these resources for my HomeLab repos. Pretty cool. And also, by the way, in the group, you can see here I'm using the data group. And I also created resources for all the different labels with a color code and the description and all that stuff. So yeah, let's go back to our test project where we have created the example repository. By the way, what is also pretty interesting, if you created a repository in the web UI before, for example, let's assume you have created a bunch of projects in here before and they are already existing in GitLab. So how do you start managing those repositories that are already existing? Because if you would go in here and define the example2 repository, and then you would go into Terraform and try to apply this, you can see this is not working because the example2 repository is already existing. Yeah, so, but there is a way how you can manage existing resources in Terraform as well. And this is by importing those into the Terraform state file. And this you can also very easily do. You just need to define in code what is existing and what resources you want to manage. And then you go in here and import them with the Terraform import command, and then the name of the repository, how you have created it in code. So this is example2. And then you need to use the ID of the repository, which you can look up in GitLab. So here, example2 is my repo that we want to import into Terraform management. Here you will find the project ID that is 45. Import the resource. And then if you execute a Terraform apply command again, you can see it knows that this is already existing. But as you can see, there are a couple of settings that we have changed in the code. And then it can apply those changes and settings on our existing repository. So yeah, we know just configured the description, so that is what has been added by Terraform. If we go back in here and refresh this, we should see the description over here, my awesome code base. And yeah, this is how you can create as many repositories as you want. You can configure as many settings as you want. You can even import existing resources on GitLab into Terraform and then use simple code files to manage your entire infrastructure. Alright guys, so yeah, that's one of the ways how you can integrate Terraform into GitLab. As I said in the beginning of this video, there's also another interesting feature that I wanted to try out, and that's using GitLab as a storage for the Terraform state files. And by the way, if you're wondering, no, what the hell is the Terraform state file and why is it so important, let me give you some context about that. Because the Terraform state file is, in simple terms, just a file that Terraform uses to keep track of the resources it manages. Like if you execute the Terraform apply command on your machine, then Terraform uses the state file to remember which resources it has already created and what settings they have, so that if you execute the apply command again, it only needs to apply things that have changed in the code. And usually this Terraform state file is stored in a simple JSON file called terraform.tfstate that is just located in the same directory where you execute your Terraform files. And this just works fine if you run this program on your local machine, but it becomes a challenge when you're trying to work with multiple people or you use it on multiple machines, because all the devices that work on this project, they must share the same tfstate file, so they all know what resources they have created and they don't try to create resources that are already existing. And by the way, this is not only important in team environments, also if you're planning to use this in CI/CD automation workflows where you need ephemeral environments running the Terraform commands like in Semaphore UI or Orchestra, you might also run into this problem. So the best way to deal with this is to store the tfstate file somewhere in a centralized storage location where all the devices that run the commands have access to. Now, one might say, well, why not just push this Terraform state file to the same Git repository you're already using for the project, so then every device can pull it down from the repo? And yes, it would technically work, but it is not a good idea to do that, because there are two problems with this approach. First, whenever you're making changes to your infrastructure via the Terraform apply command and the tf state file needs to change, it might lead to conflicts. For example, when two devices just pull down the repo and run the Terraform apply command at the same time. And the second problem is that the tf state file might also contain sensitive information about the infrastructure, such as API keys or passwords that you should generally avoid storing in a repository. So that's why it is best practice to store the tf state file on a separate storage location that also should support file locking, so that when one device runs the Terraform apply command, the tf state file becomes locked and every other process have to wait until the first one is finished, which avoids running into any conflicts. In the past, I have just used Terraform Cloud for this, because there is a free service that HashiCorp provides for managing the tf state file, and actually this is working pretty well. Terraform Cloud has also many nice features, and I originally wanted to make a video about Terraform Cloud in the past. However, because I have just deployed my self-hosted GitLab platform and it has a feature to also integrate the Terraform state file, I thought it would be just much more amazing to use my self-hosted GitLab platform for that instead of using any cloud service. By the way, if you're still excited to see a Terraform Cloud video, I would not be against making a video about it. So if you want to see that, please leave me a comment down below, so then I might do that. But yeah, I think the GitLab Terraform integration is also pretty nice for doing this. And by the way, if you want to learn more about this feature, you can just check out the official documentation on GitLab. As you can see, this is using the HTTP backend functionality in Terraform to easily store the tf state file using the GitLab API. But let's have a look together how this is working for our GitLab test project here. So what we have to do is we need to go to provider settings and add the Terraform backend in here. So here we can add a new flag. It's called backend and call this HTTP, where I need to collect the tf state file information. Then we need to go back to the terminal, because when we would just try to execute a Terraform apply commands, you can see that there is a problem that Terraform recognized. Okay, so the initial configuration of the request backend HTTP was different. We need to migrate the existing tf state local file to the new HTTP backend on GitLab. And the way you do this is, it is very well described here in this documentation. If you go down here, there is how to set up the initial backend. So we need to modify this command a little, because we have already used the Terraform state file on the local project before. So no, first of all, we need to add the project ID. So for which project we want to store it. So this is where our Terraform code is. Now we need to copy the project ID from here. So this is project ID 40. Let's go back to the terminal, paste it in here. Now we need to fill in my username. So the username of the personal access token, in my case, that's my username. And the password is the personal access token. So again, I will just use the same personal access token as I configured here. Just add it. And of course, we need to replace the address with our self-hosted instance. So that here, add it here, that's the API. So anything else should be fine. No, one thing, old state name. So that's where we're gonna change. I usually change this location to the name of the project. In my case, GitLab test 1, but it's actually up to you. You could even store different tf state files in here for different types of resources whatsoever, but I think it's better to store it in one state file name. And yeah, so this is a command to initialize a fresh new project where you haven't really applied any resources yet, because we already have done that, and we have a locally stored tf state file over here that contains information about our already created resources. We have to migrate this local tf state file to the HTTP backend, and that is by adding another command that is called migrate state. Now you can see, do you want to copy existing state to new backend? Pre-existing state was found while migrating the previous local backend to the newly configured HTTP backend, so that's what we want. So let's hit yes. And here you can see it now successfully configured the backend HTTP. Terraform will automatically use this backend unless the backend configuration changes. Now, what you should now test is execute a Terraform plan command. So here you can see no, there are no changes. So it already recognizes the tf state file correctly, so that's fine. Now, we can just use this, create different resources here and so on. Now, let's test this, and let's assume I would want to work on the same project, but on a different device. So I will just open a second terminal window. It doesn't matter if it's the same machine, but it can be a different project. For example, and let's just clone this repository here to the second machine or the second project directory. Oh yeah, of course, I need to enter clone. No, otherwise it won't work. So now let's go into this directory. As you can see, it has all the Terraform files and stuff, but it of course doesn't have the tf state file. Yeah, so if we would want to initialize the new project, now we need to use the same command that we have used over here, but without migrating the local tf state file, because this is an empty project. We haven't initialized this before. Now it's downloading the provider and everything else to this new project or this new machine. Let's also execute the Terraform plan command. So no, okay, so it doesn't have the secret value, of course. This is also something I excluded from the directory. So I will just create a new file in here. secrets.auto.tf-vars. Let's just put it in here, right? Execute Terraform plan. As you can see, there are no changes on the infrastructure. So the second device knows which resources the first device has created using Terraform. And if I now create a new resource, for example, on the second device, let's also open this in VS Code. And the second device edits something in here. For example, it creates a different project that is called example3. And pushes this to GitLab, new repo, and then needs to apply the changes. So second device will create a new repository in GitLab. And if we go to GitLab, you should also see this example3. So now I want to continue working on the first device. So the first device needs to pull down. So the first device should also have all the data. And now, this is a thing that is now important. The first device needs to know that the second device has created the example3 repository as well. So if we execute the Terraform plan command, you can see there is example 1, 2, and also 3. There's nothing you need to change. And this is how you can easily work with multiple devices, multiple people on the same Terraform managed project using the GitLab platform as a central source for the TF state file. This is super cool, and it is also very important for any CI/CD automation tasks where you're using Terraform. And by the way, what is also nice, because I've created all these different example repositories, of course I don't need them. Yeah, because we're managing this in Terraform, when I just execute the Terraform destroy command, so that will automatically destroy all the example repository resources. And those repos are now gone. Pretty cool, right? So yeah, that's how you can integrate Terraform into GitLab for amazing automation. There are so many possibilities and use cases to use it to practice DevOps techniques in your home lab without having to damage a production environment, of course. I think this is really cool. But yeah, please let me know, what do you think about GitLab and Terraform? And if you'd like to watch more tutorials from me, then check out my Patreon page. It would be so nice if you consider supporting me there, just like all these amazing dudes down here. And as always, thank you so much for watching. I'll catch you in the next video. Take care. Bye bye.